Good morning, guys. I'm going to discuss about longitudinal distances. And today we're not going to make any uh, computation except for a few. And I'll explain to you some of the uh, terms used in this in the vessel or of the subject matter, so, so that you will fully understand what I'm talking about. Actually, this is for a basic information, or this is the base on computation of the vessel is based on uh, this topic that we're going to discuss. Okay, so let's start, guys. I'll start with this one. So, it says here longitudinal distances. So it says here it has three phases with the lightship, which is an LCG, meaning longitudinal center of gravity, and the holds, all cargo holds on each hold will also have a longitudinal center of gravity. So with the compartments, within the compartments, let's say uh, the ballast tanks, fuel tanks, low oil tanks, etc. So they all have LCG, so which is the longitudinal center of gravity. And next we have the longitudinal center of buoyancy. So this is the distance of center of buoyancy. Okay. Uh, as per this figure, the buoyancy, if this is your center, this will be your LCB. The buoyancy will the forces of water will exert effort to raise this vessel up, and there's also a force here to make the vessel sink. So the center of buoyancy will be in the middle. So this will be your center of buoyancy, somewhere around here. Okay, that is what it meant. Now, center of flotation, longitudinal center of flotation, the distance of center of flotation. Your center of flotation can be in the center, or forward of your center, or up of your center. This is what you call the tipping center. Okay, so if this is your center of flotation, the tendency of the vessel forward is to go up, and your up is the tendency is to go down, because your center of rotation is somewhere around here. It's not in the middle. So when your center of rotation is forward of your amidship, somewhere here, meaning you have more weight here, so the tendency is to sink. And since you have a small weight here, the tendency of this vessel to rise. So this is your tipping center. But if your center of rotation is somewhere in the middle, which is this one, so the tipping center is zero, or there is no what you call trim, or the vessel will not, what you call that, the vessel will not sink here, and the vessel will not rise, or this will not, the vessel will not go down here, and the upper part will not rise, because you are in the center. So this will be your center of rotation, or the tipping point. This will determine if you are trimmed by the head or trim by the stern with your center of rotation. Okay, so let's go back. That is what we mean by longitudinal center of rotation. Buoyancy is what you call the force when the pressure in the water is, the buoyancy is to the pressure is going up, and also because of the weight of the vessel, the pressure will also have a pressure going down. Okay. There must be some weight here so that the pressure will, the vessel will sink, but because we have a buoyancy here, the vessel will sink only to a certain degree or drop. Okay, that's what it means here. Okay, now to continue, distances such as the values of center, longitudinal center of buoyancy and longitudinal center of rotation are measured horizontally from reference plane, which is the midship. Okay, what it means here, the LCB or LCF should have always have a reference point, for measurement. Okay, so your LCF could be here or on the up part. So this will be your reference point. Your LCB or your longitudinal center of buoyancy will also be measured from a reference point from a midship. It could be your LCB, could be forward part of the vessel, or LCB could be up part of the vessel. Okay, so that is what it meant there. Okay, the direction of measurement, either forward or up, reference to plane midship, is assigned different signs. Okay, what it means, the reference of the measurement can be LCB. Let's say, for example, LCB could be on the forward part and LCB on the up part. So it's either way, forward part or up or in the middle. And it says here, for distance measured amidship from the sign convention is normally negative sign for forward amidship and positive sign for amidship, up of amidship. You see here the sign. If this is your point of measurement or amidship, from amidship going forward, at any point here, that will be negative sign. And at the middle or your amidship, your reference point, if you are up of this reference point or amidship, then the positive sign would be positive. Could be either here, your weight could either be here, or your weight could either here, here, and here. It will always be positive, okay? Because you have a reference point from amidship going backward. On the other side, for reference point in the middle or amidship, you have forward, going forward, that will be a positive sign. Now, I want to express this one. In my opinion, they use the negative sign. So this is just a name. For example, your name is Peter. So when you say Peter, which means he is forward of your amidship because his name is Peter. On the other side, when he is behind this amidship, we call him Pedro because Pedro is behind this amidship. So it's easy to remember when you say the name Peter and Pedro. So when you say Peter, he is forward of your vessel from amidship, and Pedro will be up of your vessel or from midship because his name is Pedro. So it's easy to remember. But in this case, they use the negative sign, which means if you have a negative sign, it means you are forward or forward part of the vessel from your reference point of amidships. If you are behind this reference point or what we call the amidship, then that will be positive sign. That will be positive. So take note of that. So this is a very important. Okay. So it says here normal sign convention for values measured from amidship. So this will be the signs positive forward and a negative forward and positive up. This will be your point of reference or point of measurement. Okay. So distance starts from midship going forward and distance from midship going backward. That will be your distance up. Okay. The sign convention is reversed in some loading manuals, so it is always necessary to be sure which convention is adopted in your manual. Okay. The first thing you should do is consult your loading manual and look for this reference. If you're forward, or let's say this is hold number 1, hold number 2, the hold number 3, you will find if it is negative or positive. If your for example, if your LCG, which is number 1, if your LCG is forward, meaning LCG should be negative because you have a negative sign here. So LCG will be negative. If you see in the hydrostatic table or your LCF, this is negative sign. Negative 4, negative 20. Why? Because when you say negative, is a forward part of the vessel is somewhere around here. So what is this LCB? Here LCB is forward part of the vessel, meaning the sign should be positive because you are from amidship, venture from amidship going forward, and this will be your center of buoyancy, which is this one. Then the sign would be negative. So all negative, okay? But if your center of rotation is behind this amidship, so you're behind, backward. So this is center of rotation, this small arrow here, and this will be your center of rotation, or what we call your, let's say, tipping center. Because you are behind this amidship or point of reference from of measurement, since you are behind, then it should be a positive sign, which is your longitudinal center of rotation should be positive. Okay. So this explains why you have a negative and positive sign. Okay, but take note that measurements are always measured from your amidship or from the center of the vessel, from amidship going forward and amidship going backward. So if you're going backward, the sign should be positive. If going forward, the sign should be negative. Okay. Comparing the two systems of measurement, longitudinal distance are used in trim corrections. Okay, distance of centroids measured longitudinally from amidship, meaning all measurements here are based from amidship. So from here, you measure it going forward. You could be either here, you could be ever here, depending on your weight. So let's say this is hold number 1, hold number 2, hold number 3, and so forth. For the example, this line here from midship going forward, this is what you call the LCG of weight number 1. So from weight number 1 at the center, is measured from midship going forward. That will be your LCG of weight number 1. So what will be? It should be negative. That is so here. So this is negative LCG. Okay. And what else? This LCB, center of longitudinal center of buoyancy. From a midship here, going forward, this will be your center of buoyancy. Meaning, the center of buoyancy of the vessel is somewhere around here. Okay? Meaning, the sign should be negative because you are forward part. So the center of the vessel is negative. And that will be this one. So this will be negative sign. Then we go to this small arrow here. Is also the center of gravity, which is a little bit forward of your midship or center or reference point. So this small arrow here, which is the center of gravity from midship going to the small distance, this will be your center of gravity, which is what you call final LCG. Okay, this will be your final LCG, longitudinal center of gravity. So that will be negative. So your LCG final center of longitudinal center of gravity should be positive because you have a positive sign here, which is forward of your midship or reference point. Now we go back here. This will be your LCF. So your LCF can be around here, can also around here, depending on your weight and on your drop. Okay. So here, the small arrow here from the center of reference, which is midship, you go backward a little bit distance, and this will be your center of flotation. For example, this will be your center of flotation, and your sign will be positive. So this will be positive longitudinal center of flotation. This one. Then next, you have the weight here, number 2, on the up part from midship. So from midship, the distance going to the center of weight 2, this will be your longitudinal center of gravity. So this will be your center of gravity, small g, because you have already a big G here. So this will be your center of gravity, and you have a distance here, so that will be what you call the longitudinal center of gravity, which is positive. So this will be positive. Okay, positive. And what else? So this is your perpendicular, upper perpendicular of the vessel. This will be your, for example, the forward perpendicular of the vessel. Okay. Okay, let's continue. Now, it says here upper perpendicular because the what you call okay, so I'll explain. The ship's perpendicular of the vessel is this. This is your upper perpendicular. This will be your forward perpendicular. Okay. So the distance between your upper perpendicular will be your distance from upper perpendicular to forward perpendicular. That will be your LPP, or length between perpendiculars. from up perpendicular going backward to your from forward perpendicular going backward to your up perpendicular. This will be your length between perpendiculars. Okay, so let's see the definition. What is LPP? Length between perpendiculars. So what is the meaning of LPP? The length between perpendiculars, or what you call length between perpendiculars, or LPP. They are the same. So don't get confused. If you see these two letters of LPP, that will be the same as the length between perpendiculars. And LPP is what you call the length between perpendiculars. They are the same, okay? It's the distance measured along the summer load line place. So this is your this is your load line plane, summer load line plane. So the distance between your up perpendicular and your forward perpendicular, this arrow is what is your summer load line. This is what you call the LPP, or length between perpendiculars, or LBP. So that is what it says of this explanation. Okay? It is measured along the water line. This is the water load line. This is the summer load water plane. This is the summer load water plane, meaning maybe somewhere around here. Okay? And straight line going to your forward perpendicular. So this is what you call the summer load line. What you call that? Summer load line load water plane. Okay? The design water plane for warships. But the after to be forward from the after to the forward perpendicular, meaning from up perpendicular going to forward perpendicular. That will be your LBP or LPP, or length between perpendiculars. Okay. Now, to explain this figure, so you have your forward perpendicular, then you have your up perpendicular. If you notice in the vessel, there's a number here which is your draft. Okay, this is your forward draft, and this will also be your up draft. Okay, so there is a distance between your forward draft and your forward perpendicular. This distance is what you call the forward correction. Okay, forward correction. Forward correction is used when you're doing a draft survey calculation. So this is important to note that on board the vessel, you check your manual, loading manual, and check if there is how much is your forward correction. All vessels have this forward correction. Then I repeat, if this is your forward perpendicular and this will be your forward draft, the distance between your forward perpendicular and your forward draft is what you call the forward correction. So there's always a forward correction. On the other hand, if this is your up perpendicular and this will be your updraft, the distance from updraft to your forward perpendicular will be your up correction. So you apply this up correction to your draft survey. So with your forward correction, then you apply the draft survey. Okay. Now this updraft and this forward draft, the distance between updraft and your forward draft, that is what you call length between draft marks. meaning drop marks. This is your drop forward, and this is your drop up. So the distance between your drop up and your drop forward is what you call the length between marks, or length between drop marks. Okay, length between drop marks. Then we have, in other vessels, they have this midship correction. Okay, so it says here midship drop forward and midship drop up, and we have here midship what's this, uh, perpendicular. So this is your midship perpendicular. In other vessels, you have this midship drop mark forward and midship drop mark up. If you have this thing, then you have this in between will be your drop correction, midship drop correction up, and this will be your drop correction forward. But most vessels don't have this midship drop mark forward. It's only one here, midship. But if you encounter midship drop marks between forward and up, then you apply the midship correction forward and midship correction up. Okay? I hope that is clear. Then let's go back to our figure. Okay. Then we have here the hydrostatic table. Okay. Now I'm sorry. The LBP here. If you have a reference forward in the middle of the vessel, or point of reference or point of measurement, if this is your positive, this is your negative, if you are forward of your vessel and positive up of your vessel, then divide this LBP, or length between perpendiculars, or length between perpendiculars, from point here going to your upper perpendicular. What will be, that will be your 1/2 LBP. On the other side, from reference point of your midship going forward to your forward perpendicular, that will be also 1/2 LBP. Okay, so 1/2 plus 1/2, that will be your total LBP, length between perpendicular. That is what it means. Okay, so here, just once you check your hydrostatic table, you have a graph here, you have a distance, TPC, FTC. But look at your LCF and LCB, which is, LCF is positive, because which means if it is positive, your LCF is behind from a midship going backward. So that's why it is positive, because the side here is positive. So check the LCF. LCF is this one, center of rotation, and is a little bit backward from your center of a midship. So from your midship, there's a distance here a little bit, and backward, that will be your center of rotation, which is which is positive. So it is a positive sign here in your hydrostatic table with the corresponding graph. On the other hand, LCB, longitudinal center of buoyancy. So you see your longitudinal center of buoyancy here is on the forward part from a midship. So you see the arrow here. This is your center of buoyancy, meaning is negative sign. The sign of this figure here, or LCB, should be negative. That's why you have an LCB of negative sign. So without this diagram, if you see the negative sign of LCB, meaning is the forward part of the vessel. If you have LCF or positive sign, is on the up part of the vessel. Okay, so that is what it means here. So this is the distance from midship going forward about 4 meters, 0.21 centimeters. It's a positive sign because you are forward of your midship. If you are, the distance here is 1.25 from midship going backward is 1.25. Then your LCF is positive because you are the up part or back part of the midship. Okay, that's what it means here. Then we go down. Here in figure point 5, there's a vessel. There's another type of vessel that the point of measurement is only from your up perpendicular, not in the center. No, all measures coming from the up perpendicular. So you check here from up perpendicular going forward. This will be your weight number 2, and the second LCF or up perpendicular, which is this one, is measurement is coming from your R perpendicular, which is your central flotation, and final LCG. See, look here. Here's already forward part of your midship, but it's positive because the measurement is from your upper perpendicular going forward, passing this midship, and from this point. So that will be your final LCG from up perpendicular and LCB from up perpendicular. So from up perpendicular measured forward, passing this midship, and this will be your center of buoyancy. That will be your LCB from up perpendicular. Okay, and here you from up perpendicular, your LCG weight number 1. For example, is your hold number 1. The measurement comes from up perpendicular going forward, passing the midship. That will be your LCG or longitudinal center of gravity from up perpendicular of your weight number 1. Okay, so that's what it means here. Now from the history table, it's always LCF and LCB is positive. Okay, so if this is your drop, your LCB longitudinal center of buoyancy is positive 94, and this is your drop that LCB is positive 94.21, and your LCF is positive 88.75. Okay, there's no, all signs here are all positive, your LCF and LCB. Now, unlike on the measurement, if your measurement is from a midship, then you have a negative sign and positive sign, which is what you see in the hydrostatic table of LCB is negative here because you are on the forward part of the vessel from a midship. Pressure, point of reference in measurement is from the center or from a midship. Okay, while on the other hand, the point of reference of measurement is from the upper perpendicular. Okay, just take note of this, guys, so you will never get confused. Okay, now so we try to explain this one, converting distances measured from a midship to distance from up perpendicular and vice versa. So this one, converting distances measured from up a midship, meaning your point of reference is from a midship. Okay, this will be your point of reference. So meaning forward negative and up positive. Okay, so let's go back to the question. Okay, so distance from up perpendicular equals 1/2 LBP meaning this one, 1/2 LBP. This is from upper perpendicular going to your amidship, that will be your half LBP. If you add this forward LBP, another 1/2, that will be 2, 2, 3, 3 L, 3, what we call LBP, 3 meters, or, okay, or 3. So 1/2 plus 1/2 will be 3, okay? Then we go back to the problem. Okay, so here's a formula here. So from distance from upper perpendicular equals 1/2 LBP minus the distance from midship, okay? Meaning, for example, this is 1/2 LBP, and distance from a midship, this will be your distance weight from midship. How much will be your what you call this? What you call that one? How much will be your distance? Okay. Okay. How much will be your distance? Okay. Minus your distance of your x. Okay. Meaning, if this your 1/2 of LBP and your weight, center of gravity of your weight is here, because you have your weight here in the upper part of the vessel. This is the distance from amidship going to the center of the weight. What will be the distance here? Okay, from 1/2. Okay, it's asking what will be the distance here, because you have already your distance here of 1/2 from amidship going to your upper perpendicular, and your weight is measured from the center or amidship going backward. You have the distance here. What will be the distance between upper perpendicular to the center of the weight? That is what it means, the problem. So if this 1/2, so it says here, distance equals LCF of your upper perpendicular equals 1/2 minus your distance, or your LCF. So, okay? So, for LCF here is, for example, by this illustration, if this is your LCF, what will be the distance here? The remaining LCF. Okay? So that's what it means. So we go back. Example, your 1/2 LBP is 179.5 minus your LCF is 1.96, meaning 1.96 is from the center here minus your 1.96. For example, this 1.96. What will be the distance here of your new LCF? Okay? And the answer is, so 179.5 minus 1.96. What is 1/2 of 1.79? So this is your LBP, or length per perpendiculars. So what is 1/2 of this one? So 1/2 of this one, let's say, I'll make a Excel here. Excel. Okay. Right. Excel. Excel. This one? Yes. What is the Excel? Excel. Excel. Let's find the Excel. There he goes. Slow lang siya. Okay. How much is he? Problem it says one up of LBP 179.5. Okay, check here. Okay, this one, shipboard 26. So, how much is the LBP? Says here 179.5. So you put here 179.5. 179.5. Okay? 79.5 was here. Click, divide by 2. What is 1 half of 170.5 equals, that will be 90. Okay? Again, check. By 2. By 2 equals 90. 89.8. Okay? So next, here, you deduct this one with 1.1996. So put here 1.956. Tama ba? 1.196. Okay, 196. Okay, check. 1.196. 1.196. 196. Okay. So this one equals, click this one, minus 1.196. Then you will have answer would be 88554. Okay? What is the answer? 554. So let's put this a little bit. 544. There you are. Okay? So, again, 179.5. You bear 179.5, 1 half of 179.5, that will be 89.75. Okay? And deduct this figure by 1.96, which is here. You subtract it with 1.196, and the LCF from up perpendicular will be 88.54. That will be this one, okay? So I think that's clear. Then we go back to the other one. Converting distances measured from perpendicular to distance measured from amidship. Meaning, distance from amidship, 1/2 length between perpendiculars minus distance from up. So meaning, okay, I think, let me check. Okay, check guys. Okay. Ito ko. Ano to? Ano? Meters, converting this. Let's see. Ito. Store this one. Okay. Okay, let's go back. Ito. Okay. This was the first one that we have. So we have 88.55. Then here we have the second. So converting distances measured from up perpendicular to distance measured from amidship. Then we have here distance from amidship equals 1/2 LBP minus distance from up. So distance x equals 1/2 LBP minus distance from up. Okay? What does this mean? If this is your 1/2 LBP, and it will be the other way around from distance up to the weight, what will be your LCF here from this one going to your forward reference point? So you have there the 1/2 LBP length with perpendiculars and distance from upper perpendicular going to your weight. What will be the distance from your weight going to the reference point or your midship, a midship? Okay, that's what it means. Okay, where is it now? I think this one. So 1/2 LBP measures distance from upper perpendicular. So let's see the problem, guys. The ship's LBP is 179 and the LCB is 94 positive, meaning up. Find the LCB from amidship. This is your LCB is 94.94 from up. Okay, and find the LCB from amidship. Okay, so your 1/2 of 179.5 again. So 1/2 of this one is this one. This one, go here, paste. So this 1/2 of your LVP is 89.75. Then you have here chase here. You have, and the LCB or longitudinal center of buoyancy is 94.943. Positive because you're on the upward. Positive because of your the upward. So it says here 94.943. 94.943. Says 94.943. Is that correct? .943. Is that correct? Okay, 9.43. What will be his longitudinal center of gravity? Okay, so your 1/2 minus, excuse me, cut, put it here. Is so what is 1/2 of this one? Is 95 point. Okay, put it here. Delete again. So 1/2 of 179.5 is 89.75. So with this figure, you subtract this figure with this one, meaning 94.943. It means from your reference point going to your weight from here. Again, check the problem. The problem is the ship's LVP is 1/2. So 1/2 LCB is minus 94 forward. Meaning okay. Meaning the distance from our perpendicular going to your weight here is 94.943. Again, I repeat, the distance from our perpendicular going forward to your weight is 94.1943. What will be your distance from your weight going forward of your amidship or reference, point of reference? Okay, that is what it means there. So equals minus your 1/2 of 179.5. The answer would be 5.193. What will be the answer? -1.15. negative 0.193 forward of a midship. Forward of a midship. Why? Okay, why forward of a midship? Okay, because your one half of your LBP is 79.75, which is this one. So from here to your midship is only 89.75. So if this is your perpendicular, perpendicular to your midship, this is your midship, is 89.75. Okay, but your LCB, this here, LCB, LCB, your LCB is 94.943, meaning from your point of reference to your from up perpendicular going to your midship is 94.93. So is 5 meters more, because you're from your up perpendicular is only 89.75. But here your new LCB is 94, which is beyond this midship. So meaning 5.5 sorry, cut is meaning he is in the forward part of your midship. So it's forward. If full part is negative, so this sign should be negative. Okay, this will be negative. The sign would be negative. Okay, so again, one half of your LBP is 89.75 and your LCB is 95. From up perpendicular measured to the midship, but is more than your one half of your LBP, so it's somewhere around here, forward part of your vessel. That's why it's negative, and measurement from your midship forward is 5.190, the weight. Okay, so that is why the answer here is negative 193, forward of midship. Okay, that's clear. Okay, guys, forward. Sorry. If this your midship is forward of your midship of 5.193 meters. Okay, I hope that's clear. Then what's next? Okay, so I just explain this one, guys. This is your upper perpendicular. This will be your forward perpendicular. The distance between these two forward and upper perpendicular is what you call LPP or LBP, which is the length between perpendiculars, which is this one, guys. So the length between perpendiculars, LBP or LPP, is the same. Okay, that's what it means. Then this will be your forward perpendicular, and you have a drop here forward, right? So the distance between your forward perpendicular to your drop mark is what you call the forward correction. Okay, from your forward perpendicular is the and you have a drop mark here, forward drop mark, and the distance in between will be what you call the forward correction. This is used for drop solving. And you have here on the up part, your up perpendicular, and you have your drop mark up. The distance between up perpendicular to your drop mark up will be your up correction. Okay? So the distance between drop mark up and drop mark forward is what you call length between drop marks, or what you call length between drop marks. Okay? And here this will be your mid-shape drop. You have a forward mid-shape drop and a up mid-shape drop. So the distance between mid-shape and your forward drop mark will be your forward correction for mid-shape, and the other side is your up drop correction for mid-shape. Okay? If you don't have this correction, then you just take note of this mid-shape and you will get your mid drop. Okay? And that's it, guys. Share, thanks for watching this video. If you have any questions or comments and suggestions, don't hesitate to write in the comment section below. If you like this video, please click the like button, share, and subscribe. If you are interested in this program, I can give it to you for free. For those who are interested, write a message to my email ad. Okay? So that's it, guys. Thank you for watching and have a good day.